Okay. So today, I've mentioned to some of you na we'll be covering estimation lang muna, no? Pero I've realized na tapos na pala tayo sa anong tawag dito, sa probability. So, I think kaya nating umabot hanggang hypothesis testing ngayon, no? Okay, if isasagad natin yung 3 hours. Okay, so let's start with estimation muna. So I hope you've already read your modules, no? And for this session, mag-ano lang tayo, practice on different problems, no? Okay? So if you've read your modules, meron tayong I don't know, two types of estimators. So meron tayong tinatawag na point estimator, tapos meron tayong interval estimators. Pag point estimators, ito yung estimation based on a single value lang, no? So for example, if you have a sample standard deviation or sample mean, then that is a point estimator that is trying to represent the population for which it came from. So a sample mean, for example, is a point estimator of the population mean. Okay? But sometimes hindi enough yung point estimators. No, we need a interval estimator. So when we say interval estimator, this is where we expect the true mean. When we say true mean, that means the I don't know the population mean or whatever statistic you are or whatever statistical value you are trying to estimate. No, um, if let's say for example mean muna. So pagka sinabi nating a interval estimator of the mean, then we are saying that the true mean or the population mean lies between a particular interval, and we are sure that it lies in that interval at a certain percentage of confidence. Parang ganun yung implication ng isang estimation ng isang interval estimate. Okay? So for this case, we will be trying different examples. No? So there are 9 cases for your interval estimators, and ang first na 3 deals with the mean. No? So this is the confidence interval for the mean. Meron tayong 3 cases. Yung first is the known population standard deviation. That is what we call as case 1. Tapos case 2 is hindi known yung population standard deviation, pero yung distribution natin can be assumed to be normal. And usually we assume a normal distribution pagka yung sample size natin is large enough, no? And the sample size is large enough if we follow this formula, no? And if you notice and take note of this formula, class, no? This is n is equal to z alpha over 2 sigma over e, where e is the error based on the chosen confidence interval over 2. So if I were to put this into into an example, so pagka sinabing kunwari the true mean of the tensile strength of a particular process lies between 100 megapascal plus minus 30 megapascals. Kunwari ganun yung interval estimate. Then yung plus minus 30 na yun yung error natin. Okay? So siya yung kumbaga yung plus minus na value. Okay? So for this case, ito, you will notice na ito ay parang na-derive lang from the one of the cases na I'll be showing to you later. Okay? So as a general rule of thumb, when n is greater than 30, we usually say na large enough na yung sample size, no? And with that, we assume that the distribution is already normal. Okay? Tapos yung case 3 naman, this is a case wherein we have an unknown population standard deviation. Tapos the sample size is not large enough that we can assume normality, no? So in that case, iba na yung magiging distribution na ipa-follow natin, no? Okay, so later ipapakita ko sa inyo. Okay, so those are the 3 cases for determining confidence interval for the mean. and there are different formulas for each of them. Ito, will they basically have the same formula, no? It's a ano, no? Meron tayong a statistic multiplied by or a tabular value. Then we multiply it by some form of standard deviation, whether it's a population standard deviation or a sample standard deviation divided by square root of n. And the x bar here is the observed mean from the sample that we get. No? So again, estimators are taken from samples, no, because in most cases hindi kasi natin kayang ma-determine yung population na ano, no, na population parameter. Okay? So usually we take samples, and that from that samples we try to infer or we try to make inferences about the populations. Okay? So it's x bar plus minus a certain tabular value multiplied by a certain standard deviation divided by square root of n. So if you notice, lahat yan um, same yung form, no? So case 1, kaya siya population standard deviation because the population standard deviation is known. Tapos case 2, the population standard deviation is not known, pero the sample size is large enough that we can assume normality. Kaya yung tabular value na pipiliin natin is from the normal distribution, no? Which is the z-score. If you remember this, this is just the same as the z-score, no? Yung ginamit natin during the calculation of of continuous probability distributions, no? Okay? So ito, yung last natin is hindi known yung population standard deviation. That's why this is a sample standard deviation. Tapos dahil we cannot assume normality, instead of the z normal distribution, we use the student t distribution. I think student t distribution o basta it's a t distribution ang tawag sa kanya. Tapos meron siyang sariling tabular values. Okay? Now, let's try this example. So meron daw tayong electric firm that manufactures light bulbs that have a standard life that is approximately normally distributed with a standard deviation of 40 hours. Now, if a sample of 30 bulbs has an average of 780 hours, let's find the 96% confidence interval for the population mean. Okay, so what we are trying to find here is what is the interval for which we are 96% confident that the true mean lies on that interval. Okay, so let's try this muna, no? Itong part A muna. So before we proceed, anong case to? Tingin nyo. So try to think about it. Write it in the chat or gamitin nyo yung mics nyo if you know the answer. So is this case 1, case 2, or case 3? So ganun parati class, no? When we are doing estimation, parating we start off with identifying which case it is. Okay. Wala sumasagot. Narinig ba ako? Case 1, Aliyah. Okay. Case 1, that's actually correct, no? So why is it case 1? So it's case 1 because we are given a population standard deviation, no? So ang sabi kasi dito is known yung known sila na approximately normally distributed, and the known standard deviation is 40 hours. Okay. And that's good, Kenneth, no? So, okay. Thank you for the feedback. So it's it's a it's case 1. So for case 1, gagamitin natin is normal distribution, no? So let's do Excel. Properties ko muna, no? Ba't ganun? Excel. Okay, let's try this one first, no? So, ang sabi is meron tayong standard dev, and I'll just say stdev.p no to indicate that this is a known standard deviation, and yung known standard deviation natin is 40 hours, no? Tapos, from a sample mean of 30, meron daw tayong average na, so n becomes here 30, tapos yung x bar natin is equal to 780 hours daw. Okay? This is 780. Oops, sorry. This is 780 hours. Okay, and let me just zoom in for you guys. Okay, so meron tayong standard deviation and 780. So first, ang kailangan natin is yung z. Kaya natin i-compute yung z at 96% confidence interval. Okay, so if you know the normal distribution, for this session class, ang ituturo ko sa inyo is yung Excel method. Pero pwede nyo naman balikan yung modules natin para aralin kung paano yung kung kunwari tabular method yung ginamit. No? Okay? So Excel tayo ngayon para mas mabilis. So dito, if you remember yung normal distribution natin, and let me just draw. Okay? Kunwari lang may normal distribution tayo na ganyan. So when we say 96% distribution, 96% confidence interval, then we are saying na we have 2% dito, tapos 2% dito. So that this is the interval which is what we are looking for, itong 96. Okay? So usually, pagka hindi sinabi kung whether one-tailed test siya or two-tailed test, we say na two-tailed test siya. And for estimations, since we are estimating, no, usually we do two-tailed test yan. Pero there are cases wherein we do one-tailed test, no, and later I'll show you how we can identify one-tailed test versus two-tailed test. So for this case, itong area na to, this is 2%, this is another 2%. Tapos itong malaking area na to, this is the 96%. And we are looking for, kumbaga ang hinahanap natin is this interval. No? So we are looking for the value if this is 780, yung mean niya, and this is normally distributed. Ang hinahanap natin is what is this plus minus here. So minus in an error, an interval. So if hanapin natin yung interval na yun, parang hinahanap natin tong particular value na to, no? Kung nasaan siya dapat. Okay? So, with that, ang una natin gagawin is to identify how the normal distribution works in Excel, no? So if we do norm dot there are many ways to do this, no? Pero perhaps the simplest one is to do norm.s.in, no? So what we're saying is hahanapin natin yung inverse ng normal distribution. So when we say inverse, instead of finding the probability under the curve, ang hinahanap natin is we are given the probability or area under the curve, tapos hahanapin natin yung z-score value, which is what we are looking for, no, sa z. Usually pag nakita nyo ganito, norm.dist, and this is applies for all mga distributions dito sa sa Excel. Pagka sinabing dist, ibig sabihin nun you are given you are given a certain z-score, tapos ang hahanapin mo is the area under the curve. Okay, so yun yung ibig sabihin pagka this. Tas inverse is the opposite naman. Given kayo ng particular z-score or particular na value dito sa x-axis, tas hahanapin nyo yung area under the curve. Okay, so ang gusto natin is yung z-score. Oh, sorry, ulitin ko yun, mukhang na madog ko konti yung words ko. Pagka sinabing distribution, ang given sa atin is yung value dito sa x-axis. Tapos, ang hinahanap natin is area under the curve. Tapos, pagka inverse, alam natin yung area under the curve, tapos ang hinahanap natin yung value niya along the x-axis. Okay? So, we do norm that s.inf, tapos yung probability na hinahanap natin is yung 0.90. Gagawin natin class is 98, no? Okay, so bakit 98? Kasi we are looking for the way Excel works is ito yung hinahanap natin, no? Naghahanap kasi tayo ng z value dito. Oh, sorry. Okay. Hinahanap natin itong z value na to. So what is this z for 96%? Okay, parang ganun yung hinahanap natin, no? Z ng 96%. Okay? Etong value na to. The way Excel works is kukunin niya yung area under the curve tapos hahanapin niya yung z value na to. So in this sense, isasama natin si 2% dito, no, kasi it runs from negative infinity papunta dito sa etong end na to. Tapos ito yung hinahanap niyang z value. Okay? So you will notice that if I do, for example, 2% yung ginawa ko, since this is symmetric, I should get negative z ng 96%. Parang ganun. So, makukuha ko dapat dito is negative 2 point something. So, if, just to prove it, no? If I do equals norm.s.in ng 2%, 0.02, then I get the negative of 2.0537. 0.5375. Okay? So I hope that makes sense. And usually gusto natin na ang formulas naman natin deals with positive values. But if you think about it, etong plus minus na to, these are actually just the these are the two z values na kailangan natin para ma-produce yung plus minus. Okay? So what I mean by that is, kunwari ito, balik tayo sa PowerPoint to. So if you look at this, di ba nakalagay siya x plus minus z alpha over 2 sigma square root of n. So ang sinasabi dito is that meron kang two values na hinahanap actually. Yung positive z tapos yung negative z. Okay? Kaya siya naging plus minus. So that's why dito sa case natin, ito yung positive z, yung dito sa right tail, tapos ang negative z is the left tail. Pero since alam natin na symmetrical siya, then hindi na natin actually kailangan hanapin yung negative z, no? Ang gawin na lang natin is take the z value or the z score, tapos and I'm sorry, dapat pala we always say z ng whatever alpha over 2 na ginagamit natin, no? Ano, okay lang yan, z 96%. Okay, for the confidence interval. Kaya siya, kaya usually naka-z alpha over 2 tong notation na to. It's because traditionally, kinukuha dapat siya sa, ano no, sa sa mga statistical tables, and usually sa statistical tables based on the left tail and right tail siya. So the way you find the z-score is based on the area under the left tail or the right tail. So kaya alpha over 2 yung parating ano niya. Pero in our case, we can just say z ng 96% confidence interval. Okay? Pero para hindi tayo malito, I can equally say z98 na lang, no? So this is where z-score corresponding to 98% yung nasa left side sa kanya. Okay? Or mas nalilito ba kayo doon? Hindi ko alam kung. Before I proceed, no, kailangan kasi this is important, no? We can't do estimation if itong parang manipulation na to is hindi clear sa inyo. Malinaw ba yon? Kung bakit 98 yung ginamit natin kahit ang tinatanong ng problem is 96?
Clear naman po, sir.
Okay, that's good, no? That's good. So, ang gawin ko na lang is tanggalin ko na lang yung percentage para no. So the z value na lang. So the z value is 2.0375. Okay, so if that's the z value, then we can now compute for the e, no? So e here is equal to ano nga yun? That's z multiplied by the standard deviation, tama? Divided by square root ng n natin. Okay? So we should get 14. So our final answer will be, our confidence interval will be, and we can show this in two ways, no? Pwede siyang in terms of a, ano, no? A range. So for example, if I can do, uh, I can do lower limit and upper limits. So pwedeng gawin ko is equals, and let me, ano, no? Ano natin to. Bawasan natin ng, yan. So we can do equals, tapos ganyan. We do add. So what happens here is parang naglagay ako ng string. This is a string, no? Tapos i-connect ko siya with the lower value, which is just this one minus this one. And ulit, connect it with a string, and I do a comma. Tapos and ulit. And I do, sorry. This should be ito minus. Oh, sorry. Ito should be, yan. Tapos x bar plus naman ito. So I get the upper limit now. Okay. P3 minus B. Sorry. Nakalimutan ko yung isang and dito. So I should get something hindi pala niya na ano, no? Na ang tawag dito. Na shorten yung decimal places. Pero ito yung magiging final answer ko. 765 to 795. Parang ganun. So pwede rin, instead of writing it this way, pwede rin i-write nyo siya as the confidence interval is equal to 780 plus minus 15. Pwede naman ganyan. Okay? O kung gusto nyo, pwede rin plus. Tapos lagay nyo na lang. If you press Control U, then that's you are underlining your ano, no. So you can present it in many ways. Pwedeng ganito na form as an interval or as a range from the lower limit to the upper limit, or pwede rin as a ano, no, as a interval in terms of plus minus. Okay? So ganyan kayo nagsusulat ng final answer, no. Okay, so burahin ko muna to. So okay tayo sa first example. Okay, thank you for the feedback. So let's try the ano, no.
Sir?
Yes, go ahead.
Sir?
Go ahead.
Paano po kung yung question po dun sa number 1 is
Mm.
one-tailed test po? Paano po namin malalaman if magpa-plus or minus po kami?
Pagka one-tailed test, usually depending on the problem, no? So for example, sinabi ng problem is, specifically sinabi niya na i-estimate nyo yung, I need a specific problem, no? Para mas ma-imagine nyo siya. So, kunwari lang pinapa-estimate kayo sa seat sizes. Kunwari may ano, no? Meron tayong mga seats that could fit the average person. So may width yung seat that can fit the average person. Tapos pag sinabi natin na, kunwari, construct the interval, hindi, bangit na example yun. Kailangan pala hypothesis testing siya. Hindi ko masyadong maano, no. I need a specific example para mas maano nyo siya, mas ma-imagine niyo siya. I think sa dulo ng ano na 'to, ng lecture, meron tayong isang example of a one-tailed test. So pwede siguro mas ma-explain ko 'yon. Pero usually, based on the example, malalaman niyo naman kung lower limit yung hinahanap nyo or upper limit. So kung upper limit yung hinahanap, then we do plus the confidence interval. And pag ganon, ang mangyayari is instead of doing 98, so if we do the, ano no, if we draw our, wait lang. Parang ang magiging final niya should look something like this. So kunwari lang naging one-tailed test to in such a way na upper limit yung or from 0 to an upper limit yung hinahanap natin. Kunwari ganyan. Tapos 96%. So in this case, dito yung 96, tapos yung whole 4% is nandito na. Okay? So yung z value natin will now become equals norm.s.inf ng 0.96. So notice na mas mababa siya, no? Kasi because yung 98 kasi kanina is nandito, tama? So that is where 2.035 lies. Tapos since konti na lang yung ano natin, mas konti yung area natin na hinahanap, this now becomes ito yung 1.75 na value natin. Okay? So kumbaga mas ginagamit ang mga one-tailed test pag gusto natin mas ano no, if we already know the behavior of the or we are interested in only one part of the tail, tapos gusto natin na mas maging kumbaga mas stringent yung test, kumbaga in a manner of speaking, no. So let me think of an example, no, na madaling ma-imagine. So kunwari tensile test. Kunwari may tensile test tayo. So you're familiar with the tensile test, no? So merong tensile strength yung isang material. Tapos let's just say na may tensile strength yung isang material. Tapos gusto natin na mahanap yung interval for which naglalay yung true mean such that hindi siya nagpa-fail. Parang ganun. So if that's the case, then hindi tayo masyadong interested sa upper limit, no? Kasi anything higher will be already acceptable. Okay, so ang mas interested tayo is ano yung lower limit na yun. Tama? Kasi that is the lower boundary for which magpe-fail siya if it reaches that ano. So instead of doing 2% on both sides, ang gagawin natin yung 4% ilalagay natin sa lower side para mas ano natin. Kumbaga mas nakalimutan ko yung term, no, pero uh, parang mas stringent in a way, no, yung magiging test natin. Okay, so yun yung concept ng one-tailed test versus the two-tailed test. Okay, I probably can explain this better now with an example later. Okay.
Thank you, sir.
Okay. So thank you for that question. No, that's very interesting. Then. Okay, so let's do this one. Itong part B naman. So how large a sample is needed if we wish to be 95% confident that our sample mean will be within 10 hours of the true mean. Okay? So ang sinasabi ng problem is ilang samples dapat kukunin ko such that yung average na makukuha kong value is within plus minus 10 of the true average dapat. Okay? So ito yung let's do dito na lang sa side na to. Part B. And label ko na lang to na part A. No? Send ko na rin sa inyo to. Okay. Ito. So, we have E. Our E is equal to 10. No? Kasi gusto natin na plus minus 10 siya sa true mean. Okay? So, ang N natin is what we are looking for. So, this is what we are looking for. Tapos, Z natin is equal to norm.s.in, and we are doing 95%, no? Sorry.
Sir, ay pa pala.
Okay.
Wala pa
Thank
po
you.
kasi sa Excel.
Nga. Sorry. Hindi pala ako naka no. So, thank you guys for reminding me. So, ito si norm that, ito again, E natin is equal to 10 kasi gusto natin within plus minus 10 siya. N is what we are looking for kasi gusto natin mahanap yung number of samples needed para yung makukuha nating X bar from that sample is within plus minus 10 of the true mean. Okay? So, Z natin is equal to, and I should draw it again, no? So, always class pagka gusto nyong ma-imagine yung ano, no? We always want to draw the normal distribution, no? Para mas ma-imagine natin siya. So, we are saying here na within 95% tayo. So, kung 95 dito, therefore, tig 2.5 to. 2.5, 2.5. And kung 2.5 yan, to get the Z value, dapat ang gawin natin is kunin natin yung 97.5 na area. Tama? To get the Z value. Okay? So if we do equals norm.s.in. So the S here, class, represents ano, no? The standard normal distribution. Kapag nilagay nyo ng S, you are saying na yung mean mo is at the zero na Z-score, tapos yung standard deviation is equal to 1. Parang you are normalizing kumbaga yung ano mo. Okay? So that's equal to 0.975. Norm.s.in 0.975. So you get 1.95996. Okay? Now, if you want to compute for the standard deviation, so or the number of samples, we use the formula earlier, no? Pero a quick way of remembering the formula earlier, ito. So if you can't remember this formula, what you can do is actually just look at this formula, no? Ito. So you obviously have to remember this formula, no? So x bar plus minus z, or yung tabular value times standard deviation over square root of n. So ito kasi, this is equal to e, itong buong term na to. So if we do e is equal to z alpha over 2 times sigma over square root of n, transpose natin yung n on the left hand side of the equation, transpose yung e on the right hand side of the equation, then we get square root of n is equal to z times sigma uh, over e. Tama? So if we square the entire term, then we should get the number of samples needed para makakuha tayo ng particular na e value. Okay? So that's why ganito siya. So n is equal to z alpha over 2 sigma over e squared. So yun lang yung, you don't have to memorize this. Just remember this formula. Tapos kaya nyo nang ma-derive itong formula na to. Okay? So balik tayo sa Excel natin. We have z, we have e, tapos meron din tayong standard deviation, which is 40. So what we can do is, and sige, okay na rin yan. Although baka sige, okay na yan. So we can do is yung pwedeng ilagay ko na rin dito, no? So you can do stdev.p, or pwedeng sabihin nyo na sigma siya, no? Because sigma is the standard deviation. Kumari ganyan. So equals n now here will now be equal to 1.95, sorry, close parenthesis, ito multiplied by sigma divided by e, and all of this is a square natin siya. Okay? I-double check ko lang. Okay, so we need 61 samples para whatever, so parang ang ganito ang implication nito, class, no? So if we take 61 samples, Tapos, tinest natin siya. Tapos, kinuha natin yung average na. Whatever average we get, we are sure that we are within plus minus 10 of the true mean ng population na to, ng process na to. Kumbaga. Okay? Yun yung sinasabi niya. And notice that if we want to be more, kunwari gusto natin na within plus minus 1 lang siya. So we actually need 6,046 samples. Hindi naman. Sorry. We round up actually, no? Hindi tayo nagra-round down. We round up. So, um, dito, we need 62 samples para sure tayo na within plus minus 10. Okay? Thank you, Lawrence, for the correction. Okay? So, we round up para sure tayo within plus minus 10 tayo dito. Okay? So, notice, pagka mas tighter yung tolerance na gusto natin. So, gusto natin na within plus minus 1 tayo of the true mean, then we need 6,147 samples. Okay? So this makes sense, no? Because we all know that pagka mas maraming samples yung kinuha natin, mas mare-represent natin or mas maganda yung magiging estimation natin of the population from which we took those samples from. Okay? So kung gusto natin na mas accurate siya, accurate meaning mas mas maliit yung confidence interval, then dapat nagme-make sense na malaki yung natin. So kung gusto natin na kunwari super accurate tayo in such a way na yung makuha nating average is already a representation of the true mean, then we get a very large number, no, which is which is not practical anymore, no, in engineering cases. Okay? So ang gawin natin is pag 10 lang, 60 is a reasonable amount of number, no? So if we want our samples to be 780 plus minus 10, then we need to test at least 62 samples to be sure na within plus minus 10 yung makukuha natin na average value or X bar value. Okay? So that's estimation for mean. Proceed tayo sa next example. So meron daw tayong following measurements that were recorded for the drying time. This is in hours of a certain brand of latex paint. Tapos, assuming that the measurements represent a random sample from a normal population, we want to find a 95% prediction interval. So prediction interval is also the same as confidence interval. No? So prediction siya because we are predicting that the true mean lies within that interval. Okay? So in this case, the true drying time for this certain brand of latex paint. Okay? So how do we do this? Copying ko muna itong value na ito. No? Okay, tapos lipat tayo sa Excel natin. Ay, sorry, hindi pala ako nakalipat sa no? Sa problem. So ito yung problem natin. Pakita ko lang. So meron tayong following measurements. No? Ito yung drying time daw. Ganito siya. Tapos, we we assume na itong mga measurements na to is samples that are taken to represent the true na drying time of this brand of latex paint. Okay? So, ang gusto natin is it is estimated na yung sample na to is from a normal population, no? So that is saying na yung latex paint natin is normally distributed, no? And in most cases naman, most processes or most products or processes or variation is normally distributed. Okay? So we want to find a 95% prediction interval. Okay? So tingin nyo, anong case to? And this is a little bit harder to imagine. On one hand, pwede nyong sabihin na hindi naman large enough yung sample size, no, kasi rule of thumb is n is greater than 30. So dapat case 3 siya. Pero on the other hand, sinabi naman na and assumed to be normally distributed siya. So, tama ka, Lawrence, no? This should be case 2. Okay? So, always bantayan nyo yung class, no? So, if you assume it to be normal, then we use case 2. Pag hindi natin in-assume na normal siya, then gagamitin natin yung case 3. Okay? And if walang information about its normality, then we based it on the number of samples. Okay? So, gawa tayo ng new sheet. So, let's paste our data, no? So, meron tayong data set. Tapos, itong data set na to, this is the drying times, no? And meron tayong 15 na, no? So, the first thing we do is, since we are using case 2, ang kailangan natin is yung standard deviation value. So, stdev.s, no? Or simply just s. So, the standard deviation is, gagamitin lang natin stdev.s ng data set na to. Okay? So that is our standard deviation. So what we need now is n. So we can just do this. Tapos tingnan natin yung bottom right. The count is 15. Or pwede rin, gamit tayo ng formula, count lang tayo. We use count. Tapos ganyan. So we get n is equal to 15. So ang kulang na lang natin is the average. No? So x bar is equal to just the average of this value of this data set. Okay. So we have x bar. Kulang na lang. We have standard dev. We need the z, no? The z value is, this is at, ang sabi ng problem, we need to do a 95% prediction interval. So kung 95 siya, again, that's 95 from the left tail to the right tail, no? Or yung end na yon. So that's the case, then we do norm.s equal norm.s.in ng 97.5 yung gagamitin natin. Okay? Okay. 97.5. Sorry. Uh, this is in terms of fraction. So 0.975 yung iaano natin. Okay? So sometimes class, dahil some students like to do, di ba dito sa formula, wait lang. Kasi this is based on ano, no, yung again, this is based on yung manual method of finding the z score and the t value. Since alpha over 2 to, usually again it's over 2 because of the tail of the two-tailed na nature of the test, no. Usual ang iba ginagawa nila is they use the same alpha over 2, no, tas ninenegate na lang nila para hindi sila, or para consistent yung kung ano yung nakasulat sa formula versus kung ano yung tina-type nila sa Excel, no. So some students like to do equals negative norm.s.inf ng alpha over 2, and in this case alpha is equal to 0.05, parang 0.05 over 2, parang ganyan, which gives you the same value, no. So use whatever you feel is more comfortable. So pwedeng ito, actually ito mas ano, no, parang magiging more intuitive para sa inyo if you base it on the different formulas wherein parating z of alpha over 2 yung nakasulat, no, or t of alpha over 2 or whatever. So ito mas madali siya, mas ano, no, mas intuitive, hopefully mas intuitive para sa inyo. So you can also do this as well, no. For me, I just like to do the ano, no, hinahanap po ng yung right tail niya. So I just do z ng 1 minus alpha over 2. So parang ang hinahanap ko is ganito. Alpha over 2 lang ginagamit ko, which will give you, instead of z of alpha over 2, which will give you the same value lang naman. Okay? So use whatever you feel is more comfortable. Okay, so we have stdev.s 15, and I think we can now compute for the confidence interval, no? So we compute for E first. E is equal to that's equal to z score times your standard deviation divided by square root ng 15. Okay, so our confidence interval will be equal siya sa, and we can do lower limit, upper limit. No? So pwedeng ito mas bilis na way siguro. X bar plus minus lower limit, so therefore minus the e value. Kasi ito upper limit naman, x bar plus the upper e. So it should lie between, and you can just type this, no, kung gusto nyo. Type para na maano nyo na, ma-round down nyo na yung decimals para hindi masyadong mahaba yung magiging ano niya, yung final answer nyo. So you can do ganyan. Or pwede rin, ang gawin nyo is equals 1.9, equals 3.79 plus minus 0.49. Tapos lalagyan natin ng underline to signify plus minus siya. So pwede ganyan, no? Again, choice nyo, whatever you feel is more appealing or more, or much neater na na way of presenting the final answer. I have no preference, no. I can work with this answer or I can work with this answer. Both seems good to me. Okay? So meron pa ba tayong example? So that's for confidence interval for the means, no? So ngayon, proceed naman tayo ng confidence interval where we, wherein we are comparing means of two data set. So parang sinasabi dito is ano yung confidence interval ng difference between two means. Okay? So, yung we have three cases again ulit dito, no? So, case 4 is when the variances of the data sets are known. So, this is for both data sets, no? Tapos, case 5 is the variances of the data sets are not known pero they are assumed to be equal. And yung last case is the variances of the two data sets are not equal and they are unknown as well. Okay? So, pag ganyan, we use this equation, no? So, yung final interval niya is yung difference between the two. So, that's x bar minus x1 is within plus minus z alpha over 2 multiplied by square root ng sigma 1 over n1 plus sigma 2 over sigma 2 squared over n2. Pero pagka case 5 tayo, then we use x bar 1 minus x bar 2 squared plus minus t alpha over 2 times SP, and SP here is known as your pooled standard deviation. No? So this pooled standard deviation times square root of 1 over n1 plus 1 over n2. Tapos last, yung case 6 is yung difference in the mean of the two data sets is within plus minus t of alpha over 2 multiplied by square root of S1 variance 1 over N1, and this is this is a sample variance. No? So sample variance over N1 plus sample variance of the second data set over N2. Okay? Notice that same lang yung form actually nila lahat class, no? So meron kang this value plus the square root ng ng variance over N1 plus variance ng second data set over N2, whether that variance um, is a population variance as in case 4, a sample variance as in case 6, or a pooled na variance as in kasi pag pinasok nyo to, no, yung SP dito sa square root, magiging SP squared to, and dito S sub P squared din, which is just this pooled variance, no? Okay? So same lang actually yung formula. Pero since ang pag pooled variance kasi ibig sabihin dahil pooled siya, equal siya for both the the dataset number 1 tsaka yung dataset number 2. Kaya pwede siyang i-extract out dito sa quantity na to. Kaya siya nandito. Pero basically, it has the same form, no? Variance over n1 over the number of observations. Okay? So, ito medyo mahirap i-solve yung yung variance natin. This is equal to n1 minus 1 times s1 squared plus n2 minus 1 over times s2 squared divided by n1 plus n2 minus 2. Okay? So kanina class, hindi tayo nagkaroon ng sample wherein we did t. Pero when we do t-test, usually may degrees of freedom tayo involved. Okay? So yung degrees of freedom natin is equal to n minus 1 for case 3, no? Pero dito sa sa variances, since um we have two data sets, then the total degrees of freedom when we input it in our t.inf, ang mangyayari is i-add natin yung dalawang degrees of freedom nila. So that's n1 minus 1 plus n2 minus 1. So mag-a-add lang yung dalawang minus 1. So that gives you n1 plus n2 minus 2. Ito yung magiging degrees of freedom for the pooled standard deviation. Okay? So let's try an example. And ito for case 6. Ito yung pinakamahirap na part sa case 6, no, which is yung pag-determine ng degrees of freedom. The degrees of freedom is equal to S1 or the variance of data set 1 divided by N1 plus variance of data set 2 divided by N2. And all of those values are squared divided by variance of data set 1 over N1 squared divided by N1 minus 1 plus yung variance ng dataset 2 divided by N2, tapos i-square mo yung buong quantity na yun divided by N2 minus 1. So when you have, the good thing is if N1 and N2 are the same, if N1 and N2 are the same na size, then pwede nyo pa ma-further simplify ito, no? And I leave that exercise to you guys, no? So para magamit nyo naman siya if in cases wherein yung natin, yung sample size for dataset 1 and dataset 2 are equal, no? So definitely mas madali magagamit tong equation na to pag sinimplify natin yun. Okay? Or maybe I can probably show you, no? So let's do it in this class para meron na kayong. Let me just open my Photoshop class, no? Okay. While this is opening, so far, nakukuha pa. So yung first three cases, again, just to review, no? First three cases is for cases wherein we are trying to find the interval for which the true mean or the population mean lies given a sample na data set. Tapos yung naman, case 4 to 6 is given two data sets, hanapin natin yung true difference between or the confidence interval for which the true difference of the two means lies, no? Okay.
Sir, tanong lang po.
Yes, go ahead.
Ano po yung parang yung sa case 1 to 3 po, parang
Mm.
na-envision ko po yung gamit niya. Pero paano po yung sa 4 to 6 po? Parang practical
Yung sa
na
case
gamit
2?
po. Parang yung case 1 to 3 po, parang
Mm.
na-imagine ko pa po yung
Mm.
gamit nila. Pero yung case 4 to 6, di ba po parang difference ng two means?
Mm.
Saan po siya ginagamit po?
Nagagamit siya sa no, when we are trying to compare two, kunwari products, no? Kunwari yung product is kunwari yung isang product is meron tayong kunwari light bulb. Si light bulb of company A versus light bulb of company B. Tapos kunwari ang claim ng isang company A is our light bulbs last 1,000 hours longer than the competition. Parang ganun. So, para ma-prove natin yon, if we take samples, gusto natin na i-prove na within 1,000 na yung difference between the two means of the light bulb A and light bulb B should be within 1,000. Tapos kukunin natin yung, di ba may difference sila? Tapos yung difference nila is within, kung gusto natin i-prove yung claim na yun, no, na within 1,000 siya, then we need to get the confidence interval. Kasi kunwari, yung average ng nakuha nating value for light bulb A is, let's just say 3,000. 3,000. Tapos ang na-average na nakuha nating value for light bulb B is around uh, 2,500 kunwari. So, yung difference nila is 500, no? 500 yung hours na difference nila. Pero hindi siya yung true difference nila, hindi equal to 500 exactly, no? The true difference is plus minus a certain value pa. Okay? So usually ang etong case 4 to 6 is usually applied pagka nagko-compare tayo ng two products, no?
Okay po.
Mm. And actually later ma-realize nyo na yung confidence, actually yung estimation na formulas, pwede natin siya i-manipulate to become hypothesis testing na formula. And mas yung hypothesis testing kasi mas practical yung approach niya, no? And I'll show you the difference later. Pero generally or technically, they are the same formula, iba lang yung parang perspective na tinitingnan natin. So, Pico, later on, pagka nag-hypothesis testing na tayo, mas magme-make sense sa inyo yung case 4 to case 6. Okay? And eto no, ano no, yung yung cases na i-discuss natin for estimation is the same cases na gagawin natin for hypothesis testing. Okay. So thank you for that note, David, Russell. Okay, so proceed tayo sa, let's try to simplify this this formula. Okay. Para pwede niyo siyang magamit, no? And I think sa isang example natin later, magagamit natin siya. So kailangan natin siyang i-simplify. Okay? So mukhang madali lang naman i-simplify to if we have V is equal to S1 over N, and gagawin natin since equal sila, gawin na natin N siya, no? Plus S2 squared, again variance yung pag skinare natin yung standard deviation, that is equal to a variance, no? So pwede ko na tong pwede na siya mag-fall under 1 ko na siya, N, tapos over S1 over N1 squared plus S2 N2 squared divided by N minus 1. Tama? And tama pala. This is equal to N na siya. Okay? And if I remember correctly, parang madali yung formula nito eh. Pagka na simplify natin. So, we can do S1 squared plus S2 squared. Squared natin to and n squared. Tapos, iakyat na natin tong n minus 1 no, para hindi na natin problemahin to. Then, we get S1 squared. Tapos, squared pa. So, magiging S1 to the 4th plus S2 to the 4th over n squared. Tama? And,
Yes po.
magka-cancel out to, no? So, magiging S1 squared plus S2 squared divided by S4 S2 to the 4 times n minus 1. Okay? Hindi siya ganun kaya pa ba natin ito ma-further? Hindi na, no? Hindi na natin kaya ma-further, ano pa to? Simplify. So, eto na yung ano natin. Pagka-equal yung number of ano nila, pwedeng instead of the longer formula, ito na lang gagamitin natin. When n is equal no, for both case 1 and case 2. Lawrence has a question, no? Na to take into account na po ba ng formulas for cases 4 to 6 yung parang relative error sa dalawang means po? Parang error. Yes, parang ganun yung ano natin, sinasabi sa formula na yun. Na kung baga since si true mean ng and that's a very good observation, Lawrence, no? Parang ang ginagawa kasi ng formula for estimation of the comparison of two means is that since we acknowledge na the true mean of one data set lies between a certain confidence interval, tapos the true mean of the other data set lies between a certain confidence interval, then if we get the difference between the both of them, uh, dapat yung true mean true difference nila should be along a certain confidence interval pa rin. Pero hindi siya as straightforward as just adding the two intervals, no, hindi siya ganun. Okay? Pero of course taken into account na yung dalawang intervals nila in a way. Okay? So, balik tayo sa ano, no? Sa problem natin. So let's try this problem, no? So we have the following data representing the running times of films produced by two motion pictures. So meron tayong Company 1 and Company 2. And yung films nila last on average etong mga data na to. Okay? And this is in minutes. So compute for a 90% confidence interval for the two means assuming that they are normally distributed with equal variance. So ito, equal variance, normally distributed. This is case
5.
5. That's correct, no? So, hindi binigay, walang known variance na binigay, pero alam natin na equal sila or approximately equal. So, kailangan lang natin mag-compute ng pooled na variance para this case, no? Okay? So, let's balik tayo sa Excel tayo. Now, if we let me just copy the data set, no? So may two data sets. Now, first, ang gagawin ko is compute muna tayo ng mga mga point estimators muna. So let's do standard deviation first. So let's do stdev.s is equal to just stdev nitong values na to. Actually, mas maganda kung if I do usually class, no, what I like to do in this cases is minamatch ko kung paano ni-layout yung data set, no? So this is grouped by rows. So ang gagawin ko is i-group ko rin by rows yung ano ko. So pwedeng ganyan siya para pag nag-drag ako, mas madali siya, no? So if I do standard deviation, then this is just htdev.s ng dataset 1 and I can include the blank cells, no? Kasi si Excel naman ino-omit niya yung blank cells. Para pag ganyan, i-drag down ko na lang siya ng ganyan. So this gives me the standard deviation of the second dataset, no? Now we can take the average as well. So X bar. So this is just average nitong values na to. Then what we need, yung Z is common for both. Ano pa bang kailangan natin? We have your Z, standard dev, yung count. Tama. Kailangan natin yung count. So N is equal to count. Although obvious naman kung ano yung count na. Pero I just like to do count na formula class, no? Kasi gusto ko masanay ako sa mga large data, no? So for example, if I have a larger data set, it would be arduous for me to parang count the number of observations pa. So I just like to do count na lang, no? Yung formula na count para si Excel na yung magka-count for me. Okay? So I think we have everything we need. Tapos kailangan na lang natin mag-compute ng pooled standard deviation. And I know that there is a pooled standard deviation na formula, no? Let me just find it, no? Kung gusto natin maging ano, or dito pala yun. So we can do the calculations and I'll also show you the manual calculations ng SP or quote-unquote manual. Pero meron kasing dito sa data analysis, if you go to our data analysis toolpack, meron siyang this is assuming this is t-test assuming unequal variance. We are assuming equal variances, no? So ito. Actually, hypothesis testing na to pero we can cheat a little class, no? So ang gagawin natin is include natin yung dataset na to. Oh, tama. Tapos wala tayong mamaya later this will make sense no hypothesized mean difference pero wala muna tayong no. Tapos ano yung confidence interval na hinahanap sa atin? Confidence interval is at 90% daw. So we do 90%. Ay, sorry, hindi nyo nakikita yung ano, no? Kailangan ko ata ipakita yung buong screen ko. Ayan. So, ayan, ulitin ko na lang para mas makita nyo. Hindi pala pinapakita yung ano. So, if you do data, punta kayo sa data analysis. Tapos may magpa-pop up na ano, toolbar or dialog box. Tapos dito sa dialog box, ang piliin natin is the t-test for two samples assuming equal variances. Okay, so for now, although this is for t-test, again, kasi yung estimation and t-test are very much related. No? Estimation is just more of confidence interval while si hypothesis testing is actually trying to test an assertion, no? Or a hypothesis. Okay? So dito, in this case, wala naman tayong ina-assert, no? So this becomes a hypothesis testing problem if, for example, may ina-assert tayo na kunwari, company 1 is has films that are longer than company 2. In that case, parang nagkakaroon na tayo ng assertion, no? Pero dito, gusto lang natin mahanap na ano kaya yung difference in the film durations of company 1 and company 2. Okay? So parang ganun siya. Okay, so what we do is we select this one. And ito class, ginagamit ko lang just for a shortcut, no? Parang ano. So again, pwedeng i-include nyo yung blank cells or pwedeng ito lang. No? So hypothesized mean difference. Ito yung pagka again nag-assert tayo na kunwari parang I think company 1 is longer than company 2 by 30 minutes. Parang ganun. So dito nyo ilalagay yung hypothesized mean difference. Pero right now wala man hindi natin in fact we are not doing hypothesis testing. Ang gusto lang natin kasi is maghanap tayo or ma-shortcut natin yung paghanap ng pool standard deviation and the other values as well. No? So alpha natin is since 90%, so we do 0.1. Wala tayong labels. So labels is just pag dinrag nyo siya, kung meron bang header or kung meron siyang column header or row header. No? So in this case, wala naman tayong headers. So no labels. Output range, pili lang tayo ng random cell na kung saan niya pwedeng insert. Pwedeng dyan lang. No? And if we press OK, meron siyang pinapakita na ganito. And eto, the good thing about this is, nandito na yung pooled variance, no? So, we can just copy this value, no? So, pooled variance is this one. Tapos, actually, nandito na rin pala ang variance, no? So, if we get and I forgot to add variance, no? So, if you insert variance is just equal to eto squared. Or pwede ding var.s, no? So you can see na it has the same variance. No? Ito and ito. Mean also is also given 98.4110. So essentially shortcut talaga tong ano no. Pag gumamit tayo ng yung data analysis toolpack no. Observations is also given. So n is given 5 and 7. Tapos pooled variance is given and ito yung pinakagusto natin no. So si t statistic ito na yung t value na hinahanap natin. Pero let's try to compute manually no kung ano yung magiging t statistic na. So, let's also try to do sige, i-retain ko to for comparison purposes no. Pero let's try to compute the pooled variance muna. So, if we do the formula and I myself cannot memorize the formula no. So, copy ko lang yung formula muna dito. So, if we do n minus 1, so that's n minus 1 multiplied by S1, variance 1. So, this value here plus n minus 2. Hindi na pala necessary itong stdev class, no? Kasi puro variances pala yung dinideal with ng ano natin ng case 4 to 6. So pwedeng instead of finding stdev.s, dapat var.s na lang ginawa natin. Okay? So this is plus n minus 2. This one minus, n2 minus 1 I should say. Multiplied by s2 which is this value. S2 squared, again, variant lang siya. No? And ito, lahat ng to, i-divide natin by the quantity n1 plus n2 minus 2. Okay, and you should see that it has the same value, no? Yung pooled standard deviation na to. Okay? So, after that, we compute for t. So, our t is equal to, that's t is equal to t in, and we can do two-tailed or one-tailed. Pagka ginawa nating two-tailed, ang automatic always positive value yung nakukuha dito. No? So, we can do two-tailed, tapos probability is equal to yung alpha over 2, no? Kasi we're looking for the area under the curve. So, alpha natin is 10. So, probability is 0.1 over 2. Okay? Degrees of freedom natin is N1 plus N2 minus 2. Okay? Parang ganyan. Or we could equally have done T and again, choose which one you prefer class, no? So, pwedeng ganito. Returns the left tail test. So, kung kumbaga ang sinasabi dito is from negative infinity up to a particular T value. Okay? So, we can do And thankfully, si T distribution is also a parang anong term doon, is a symmetrical distribution din. So we can do 0.95 and we'd use the same degrees of freedom, no? Ito plus ito minus 2. Oh, bakit ganun? Wait lang class ha. 0.1/2. This should be equal, no? Let me just do equals t.inv naman ginawa ko. T.inv ng 0.1 minus 2. Dapat ang makukuha ko dito is negative. Interesting. Hindi siya hindi pala symmetrical. I'm sorry. Ay di sa tama. Kasi 0.1 ginawa ko. Dapat 0.1/2. Tama nga. So ito nga siya. Okay. So kaya siya negative nung and we can do negative nito para positive value makuha natin. Mukhang ito yung tama no kasi 1.8. I'm not quite sure bakit 2.end. I'm sorry. Dapat hindi natin inato to class no. Hindi dapat natin divide by 2 kasi sa pag gumamit tayo ng t.m.2t, ang ilalagay natin is yung alpha mismo ng buong ah, alpha ng left tail plus right tail. So if I do this, it should give me the same value na. Okay? So dapat lang hindi tayo nag-divide by 2. Sorry. Okay? So you can use either method, no? Pwedeng t.m.2t tapos ang ilagay nyo na probability is the alpha itself, not alpha over 2. Tapos si Excel na bahala mag-divide by 2 doon sa ano kasi naka 2t. 2t here represents the two-tailed test. Okay? Tapos pwede rin ang gawin nyo is yung tulad ng analysis na ginawa natin sa Z, no? Wherein from 0 to a particular na end, 0 to the right tail. So ang ginawa ko is from 0 to 0.95. This is just equal to 1 minus parang 1 minus alpha over 2. Parang ganun siya. So you can do that as well. Or pwede ring negative ng alpha over 2. So whichever you feel is more comfortable or which is easier to use. Now personally, when I'm using t-test, usually I like to just do t.in.2t, no? Tapos para ilagay ko na lang yung entire probability and not divided by 2. Again, personal preference lang kung ano yung mas comfortable kayo. Tapos nakalagay naman dito yung 1. Yung one-tail test na to, this is when you are analyzing one-tail test, meaning sure ka na, kunwari, sure ka na ang different, yung isang company dito is larger than the other company. So in that case, for hypothesis testing, dapat ilagay mo yung isang tail or i-combine mo yung isang tail doon uh, sa kabilang tail na appropriate. So more on that later no when we do hypothesis testing. Okay? Ito mga critical values later i-discuss ko din yung p-test no. So we can probably delete this now no para hindi tayo malito. Pero that's just two ways you can solve for the different values no. So if ayaw nyo na mag-solve ng mga ganitong values, pwede naman gamitin nyo na lang yung data analysis toolpack tapos from there extract nyo na lang yung relevant values para makuha yung E. So now that I have this value, pwede na ako mag-compute ng E ko and E is equal to yung T value which is this one multiplied by the ulit yun and let me just balik tayo sa ano Kanina pa pala ako nandito, no? Sorry. Sige, mamaya balikan na lang natin. So this is t multiplied by the square root of the variance over the count plus the variance of the data set 2 over count. Okay? So, ibalik lang natin. So again, hopefully nakita nyo ba yung ginawa ko, yung two cases? Or hindi nyo nakita kasi iba yung screen na pinakita ko? Anyway, eto siya. Yung first case is this one. Ang gawin natin is t dot in the 2t tapos ang first argument is the entire na no alpha. So hindi natin i-divide by 2. Tapos yung degrees of freedom which is just n1 plus n2 minus 2. Okay, pwedeng ganyan. Or gawin natin is t dot in tapos yung probability natin is 1 minus alpha over 2 which is just equal to 0.95 lang to, no? So 0.95 times degrees of freedom, again, the same degrees of freedom. Gives you the same value. Tapos pag gusto naman natin yung left tail, pwede ring negative ng t dot in ng 0.1 over 2 which gives us your itong value na to. Okay, so that's this is just again the degrees of freedom. So you can use either way. Whichever you feel is more comfortable, yun na lang gamitin nyo. Okay? So if I do t multiplied by the square root ng variance over...
Sir, yung formula po ng case 6 po yung ginagamit niyo po, sir. Case 5 po dapat. Yung may S-fold po.
Tama. Thank you. So ang gagamitin natin is pwedeng ito, yung pooled value divided by ipapasok ko na, no, doon sa square root sign para hindi na ako
nasa labas po yung S-fold doon sa formula po. Hindi po siya nasa loob ng square root po.
Kasi itong itong SP kasi this is the variance. Pooled variance kasi to, hindi yung pooled standard deviation. Kaya ang gagawin ko na lang is ipapasok ko na lang sa loob as opposed to kukunin ko pa yung square root. Pero pwede rin naman, kung kukunin ko yung square root nito, this is now my SP. Ito yung pooled standard deviation. This is this is the pooled variance.
Okay po.
So sige, you can do it either way, no? Pero gawin ko na lang is ganyan times square root para lang ma-maintain natin yung parang form, no, na it's a variance over over a count na form ng equation, no. So ito over ito plus this one over this one. So we should get 27.1. Okay? So ito 27.1, ito na yung magiging interval natin or yung error or yung plus minus para sa interval natin. Okay? So, we have the average which is equal to pwedeng x bar 1 minus x bar 2. Pwede ring x bar 2 minus x bar 1. Hindi naman nagmamatter, no? So, if we do x bar 1 minus x bar 2, so that's eto minus eto. It's x bar 2 minus, and let's do both cases, no? Parang ganyan. So, yung lower limit natin is, and later, move natin to. Lower limit is equal to this one plus minus. Wait. Dapat positive yung isa. Select rin natin. Plus ito. Tapos ito, lower limit, upper limit. You will see na Okay? So they mean the same thing, no? Parang ano lang siya, it's from negative 39 to 14 if we are looking at x bar 1 minus x bar 2, or pwede ring from negative 14 to 39 if we are looking at x bar 2 minus x bar 1, which makes sense, no, na dapat negative lang siya nung two ends natin. Tama? Okay, so we now have our confidence interval. So again, if our confidence interval, we can write it in two ways. Pwedeng 27.1 plus minus, sorry. We have negative 12.314, if again we are using x bar 1 minus x bar 2, no? Yun naman yung standard x bar 1 minus x bar 2 plus minus 27.1. Oh, huwag natin equals. Plus minus. Hindi formula yung ginagawa natin. Oh, nag-automatic siya. So, if that happens, class, no, ang gagawin natin is we place a single quotation mark. So, itong single quotation mark or yung apostrophe natin will indicate that you are typing in a string, no? So, ifo-force mo kumbaga sa Excel na i-recognize yung next few numbers na ito-type mo as a string. So, magiging ganyan siya. So, string na siya and I can do yan. Or pwede rin confidence interval ko is in term of the upper limit and lower limit. So, I can do negative 41 to 14.78. Okay? Okay, malinaw ba?
Yes
Okay.
po.
Thank you. So, let's do one more problem, tas break tayo ng siguro 10 minutes. Tapos proceed ulit tayo. So, ito, confidence interval, two different blends. I think we can skip this part, no? Pero basically, ano lang naman to. Sige, pwede siguro ang gawin natin is identify lang natin kung ano case siya. Okay? So ito, two different brands of latex paint are being considered for use. 15 specimens of each type of paint were selected and the drying time in ours were as follows. So assume a drying time is normally distributed with sigma A is equal to sigma B. Find a 95 confidence interval on mu B minus mu A, where mu A and mu B are the mean drying times. Okay? So dito class, kailangan natin i-ano, no? I-honor yung kung ano yung tinatanong ng problem. So, ang tinatanong ng problem kasi dito is mu B minus mu A. Therefore, ang gagawin natin is dun sa pagka nag-compute na tayo ng lower limit and upper limit, dapat etong mean nito minus mean nito. So, sa first problem kasi, walang sinabi, no, kung ano yung kukunin, kung mu1 minus mu2 ba or mu2 minus mu1. Ang sinabi lang is confidence interval for the two means lang, no? So, kaya hindi nagmamatter kung binaliktad natin. Whoops. So, ito, sorry, ulitin ko lang yung sinabi ko. So, ito, again, dito, two different brands of latex are to be used. Tapos, meron tayong data set na ganito, 15 specimens each. Tapos, dito, specifically, tinatanong niya yung mu B minus mu A. So, kung tinanong yung mu B minus mu A, therefore, pipiliin natin yung or gagawa tayo ng mean na ito, mu nito or mean nito minus mean nito. So, pag nag-establish tayo ng upper limits and lower limits, kailangan natin i-consider na mu B minus mu A yung tinatanong niya. As opposed to yung previous problem na again, hindi sinabi kung alin yung kung mu1 minus mu2 ba or mu2 minus mu1. Parang blanket lang yung sinabi niya na confidence interval for the difference of the two means, no? So pag ganon, okay lang. Hindi man nagmamatter kung binaliktad mo or not. Okay? So eto, if this is the case, no, what do you think is the appropriate case number for this one?
Sir, hula lang. Ano po?
Go
Case
ahead.
4. Case
Case
4
4. Hmm.
kasi po Kasi po sigma po yung gamit, hindi po yung letter S.
Ah, pwede sana, pero etong bagay kasi medyo confusing. Sigma yung gamit niya which means na population siya, no? Pwede sana kaso ang problema hindi kasi binigay yung no, yung variance. So therefore sample pa rin talaga to. Parang minsan kasi loose nilang ginagamit na kahit when they mean. Although ang sinasabi naman dito is yung variance ng true populations from which these samples came from. So pagka ganyan, dapat case 5 tayo. Kasi this is where yung variance natin is known, no? Or the variance is known to be equal pero hindi natin alam kung ano yung exact value niya. Okay? So kaya tayo magde-depend doon sa pooled standard deviation kasi hindi known yung natin. Okay? Pero pagka kunwari, ito din yung ang siguro ang mga pwedeng trick dito class no is if may binigay na pag sinabing the drying time is normally distributed and they are equal. So kumare ganito. Tapos baka mag-click sa inyo na okay, sabi kasi pag equal automatic case 5. Pero dapat si case 5 bukod sa equal siya dapat unknown din yung standard yung variances, no? So what if kunwari equal sila pero known? Would that be case 5 or case 4? Tingin nyo. Equal and it is known.
Case 4 po.
Case 4, that's correct, no? So whether the variances are equal or not, as long as they are known, they will always fall under case 4. Okay? So in this case, case 5 yung gagamitin natin. Tapos we do the same steps much as we did dito sa case na to, no? So almost the same naman yung gagawin natin. Okay, ito taxi company, try natin to. Taxi company is trying to decide whether to purchase brand A or brand B for its fleet of taxis to estimate the difference in the two brands. An experiment is conducted using 12 of each brand. The tires are run until they wear out. Tapos yung results is ganito, no? Brand A is 300 kilometers. Yung average, tapos with a standard deviation of 5,000 kilometers. Yung brand B has 36,300 kilometers pala ang ibig sabihin nito. So brand B is has a average of 38,100 kilometers but a standard deviation of 6,100 kilometers. Okay, so compute a 95% confidence interval for mu A minus mu B, assuming that populations to be approximately normally distributed. You may not assume that the variances are equal. Okay, so sabi hindi daw equal ang variance, hindi rin known ang variance, tama? Although known ang sample variance, pero ang true variance or the population variance, again, kasi whenever we say true variance or true mean, we always mean the population na value, no, or population parameter. Okay, so if ganito siya, what do you think? 4, 5, or 6? Case 6, okay. May nagsabing case 4. There are many saying case 6. So actually the correct answer is case 6, no? Kasi again, whenever it is not given, if it is not known, yung mga variances, then it's always case 6. So ito, hindi kasi to true variance, no? This is from the sample kasi to. So since it's a sample, then hindi siya case 4. Okay? Tapos automatic hindi na siya case 5, no? Kasi parang explicitly sinabi, you may not assume that the variances are equal. Okay? So obviously hindi na siya case 5. Okay? Tapos ang maganda dito class no kasi hindi ang data na binigay is a average and a variance na or a standard deviation which you can take the variance out of it. So hindi na kailangan na mag-compute pa kayo using a data set. Hindi niyo na kailangan kumbaga i-compute individually yung mga values na yun. Pwedeng diretso na. The bad thing is yung mahirap sa ganitong problem is that hindi mo magagamit yung data analysis tool pack. Kasi pagka kung yung data analysis tool pack natin and transition, no? Yung data analysis tool pack kasi nagwo-work lang pagka actual data ang binigay, no? So kunwari pwede sana ang gawin natin is t-test two samples assuming unequal variance. Tapos range ng ganito tapos pwede tayong makakompute ng mga different values na no. Pati kasama na yung mga t-test yung mga values doon. Pero since hindi siya nakaano, kailangan manual natin i-compute lahat. Okay? So, ito actually class, no? If you think about it, ito, itong problem na to, actually mas more appropriate siya na i-hypothesis testing, no? Kasi if you look at it, gusto niya explicitly malaman if yung brand A is better or which brand is better, si brand A or brand B. In this case, hindi ka interested masyado dapat sa interval nila, no? Wala kang interest kung ano yung interval ng difference between the two. Parang interested ka is which one is better. So, or if there is in fact a difference between the two of them. So, dapat dun mas appropriate sa problem na to na mag-hypothesis testing tayo. A question from Lawrence before we take a break. If normal po ba yung distribution ng population, pwede bang i-assume na equal yung sample sa population deviation? Hindi natin pwedeng i-assume yun, no? Parang ang sinasabi lang is if normally distributed siya, pwede nating i-estimate yung interval using a sample standard deviation as opposed to a population standard deviation. Parang ganun yung ibig sabihin. Okay. So, let's take a short break, no? Let's do 5 minutes. Water break lang siguro at saka um so gawin na nating saktong 10:20. Balik tayo 10:20 tapos proceed tayo sa last remaining. And mukhang hindi nga tayo haabot sa hypothesis testing, no? Masyadong mahaba yung estimation. Yung hypothesis testing um or okay lang ba na hindi ko alam. Kasi let's check the schedule, no? Before you take a break. Let's just check the schedule first. Dapat ba tapos na tayo ba hypothesis testing by now? Ay, sorry. Maling course guide yung tinitingnan ko. Yan na natin, guys. No? We are now March 26. Dapat dapat tapos na pala tayo ng hypothesis testing by now, no? So, since we only meet once a week, no, so we can only cover one. So, gusto nyo ba na kasi similar lang naman yung formula, ang suggestion ko is 'di ba case 1 to 6 gumamit tayo ng estimation. Hypothesis testing naman tayo for case 7 to 9. Ganun na lang gawin natin. Okay ba 'yon? Okay, sige, ganun na lang gawin natin. Tapos i-leave ko na lang sa inyo. Just read the modules again para makita niyo yung difference on yung estimation and hypothesis testing. Okay? Tapos yun. Okay. Sige, so let's take a short break muna. Balik tayo 5 minutes, 10:20. Kuha lang din ako tubig. Okay, I think we can resume again, class, no? So let me open up my PowerPoint. Okay. So balik tayo dito, no? So para lang may idea kayo on how confidence interval is different um from your hypothesis testing, and before I proceed, may tanong pala dito from Martin. Do we have a discussion sa April 7? So um April 7 is after Holy Week na yan, no? Yes, meron tayong discussion, and let me just look at the ano, no. April 7. Okay. Hanggang April 7 pala yung hypothesis testing. Sorry, mali yung tingin ko, class, no? So thank you, ano, no, Martin, for pointing this out. Ito pala, class. Estimation. Okay, sorry. So hypothesis testing, because it's quite long, no? Aabot pala siya ng April 7. So okay pala na kahit sa April 7 tayo mag-discuss ng hypothesis testing. So continue na lang natin yung estimation ngayon, no? Okay lang ba? Tapos para if ever din pwede tayong matapos ng maaga kung maka-cover natin lahat ng ano ng cases today. Okay lang? So sa ano na lang tayo sa April 7 na lang tayo mag-hypothesis testing. Okay, thank you, Martin, no, for pointing that out. Kaya pala I was thinking na masyadong mabilis nga yung ano natin, yung parang ano, no, yung pace kung by now tapos na tayo na hypothesis testing, when usually kung face to face this usually takes 3 weeks, no, para matapos. So this makes much more sense na. Okay? Okay, let's continue on with ano na lang, confidence interval. So we ended with ano, no? And gusto niyo ba gawin natin 'to? Pero let's do this problem. Eto, tapos ang gamitin natin is instead of ano, instead of the usual na long method, gamitin natin yung faster method na data analysis toolpack lang. Okay? So let's do
Okay lang
this.
po.
Okay, thank you for the feedback. So, copy natin yung data, no? And unfortunately, yung data na to is hindi siya ano, no. Hindi siya naka-table, naka-ano kasi to, PDF. So copyin ko na lang. Tapos if may nakita kayong maling input ko, class, pakisabi na lang, no. 3.6, 0.7, 3.3, 5.2, 4.2, 2.9, 4.4, sorry, 5.2, 4, 4.1, 3.4. Okay? So, eto, class, gawin ko na lang is ganun ko siya. Paint A para naka-columns ako. If I have a choice, I always like columns versus ano, no, rows, class, no. It's always much simpler to work with, no. Lalo na pag nag-ano tayo, yung nag-proceed na tayo sa mga statistical tests. Usually mas convenient parati pag naka-rows yung ano natin, yung arrangement ng data. 5.5, 6.2, 5.1, and 5.4. 4.8 yung last natin. Okay? So, let's do quick lang na analysis of this one. What we can do is, and pwede ko na full screen siya. So, what we can do is, data ulit, data analysis. We'll do t-test assuming unequal variances. Tama? Yun naman yung hinihingi ng problem, no? Sabi sa problem na you cannot assume that they have, sorry. Normally find where you, sorry. Ito pala yung case wherein equal yung variance niya. So what we do is, and again, balik na tayo dito kasi hindi nakikita sa Excel. Yan. Kita nyo na yung toolpack. Ang pipiliin ko is assuming equal variances. So, ganyan. So, I'll do ito. This is my data set A. This is, and pwede rin class actually na ganito ko siya, no? And data set B. Sama ko yung labels, pero dapat i-tick ko tong labels na to. So, wala muna tayong, this is not hypothesis testing. So, wala muna ako ilalagay na hypothesis mean difference, no? And sa problem, ang sabi is 95% confidence interval. So, what I'll do is, I'll do 0.05 alpha. And output range ko, I'll just place it somewhere here. Okay? Sorry. Tama ba? B1 to B6 labels. Yeah. So maganda doon pagka ginawa niyo yung labels is siya mismo maglalagay ng mga headers na to, no? So, paint A, paint B kasi yun yung nakalagay kong header. So, it becomes more convenient, no, pag ganun yung ginawa niyo. So, ito, meron tayong pooled variance, meron na tayong observations, meron na tayong variance and mean. So, pwedeng gawin natin is, ang tinatanong ng problem is actually mu B minus mu A, no? Parang ganyan. So, I'll just use U, although mu dapat siya. Sige. Mu B minus mu A. Although, ito is, sige mamaya. X bar dapat to, pero kumbaga kinukuha kasi natin yung confidence interval ng true mean difference, kaya mu yung ginagamit nating term. So ito is equal to this one minus this one. Mu B. Sorry, baliktad. Ito minus this one. Actually, X bar B na lang para mas madali. B minus X bar A. Para later na tayo confidence interval. Okay, so tapos yung SP natin is equal to, pwedeng i-square root na lang natin, no? Sige, labas natin siya. So this is the pool variance. Tapos we already have our T critical or our T critical for two-tailed test. So pwedeng T is equal to this value. Okay? And just to be sure, no? Pwede tayo T dot inv dot 2T ng 0.05. Tapos degrees of freedom natin is 30 minus 2. Tama? Kasi 15 plus 15 minus 2. And it's the same, no? Okay? So, that's T. Ano kailangan pa natin? Variances also given. So, pwede na mag-compute tayo ng E, no? E is equal to SP. Sorry. Is equal to T times SP. So, eto, nilabas ko na siya. Kasi square root ko na eh. So, nasa labas na siya ng square root dito. So, 1 over, ano na lang to, class, no? 1 over n na lang to. Tama? 1 over 15. Sorry. Tama. Plus 1 over 20. Tama? Tama nga ba? Let me just double check my equation. No? E. Tama. So, again, case 6 to, no? So, meron na tayong E. So, pwedeng confidence interval natin for mu bar minus for mu B minus mu A is equal to, we can place it as lower limit lang tayo, upper limit. And sige, diretso ko na yung ano na lang, plus minus na notation. So I can do 1.12 plus minus 0.57. And this is my Okay? So, yan. So, mas mabilis pagka gumamit tayo ng ganito, no? Again, we're not actually doing t-test. Ginamit lang natin yung t-test para lang makuha yung necessary na values para magawa natin siya ng confidence interval. Okay? Oh, ni-reference ko pala siya. So what I can do is, anytime you do something like this class, no, na kunwari na reference nyo ng ganyan, pwede actually ang gawin nyo na lang is, copy nyo siya, tapos paste special, tapos itong values. Ibig sabihin yan, ipapaste niya as values. So para pag dinilit nyo to, si E pala, naka-reference siya to something. Yung 15. Sige, yung lahat na lang iyan ako. Paste special. Although, wag nyo na lang i-delete pala to class, no, kasi para masanay kayo na ang ano kasi the way we check your exams or your quizzes is i-check namin itong formulas na ginamit nyo. Okay? So kung hindi namin makita kung saan siya nanggaling, then ano kami, parang kumbaga wala kaming solution. Hindi nyo pinakita yung solution nyo, kumbaga kung if this were a written test, no, it's as if hindi nyo pinakita yung solution nyo. Final answer lang binigay nyo. So pagka ganito na lang, pakita nyo, i-retain nyo na lang to kahit hindi hypothesis testing talaga ginawa natin. So you can do is just delete this. Tapos ganyan na lang. Tapos para alam namin na kung ano yung mga reference cells na ginamit nyo. Okay? So wag nyo na lang i-copy as and paste as values. Okay? Mali na ba yan? Okay. So yan. Medyo madali lang, no? Pagka gumamit tayo ng data tool pack. Okay. So balik tayo dito. Okay. Now let's do case 7. And case 7 is what we call as a paired observation, no? So paired observations is parang similar din siya sa comparing two means. Pero in this case, you only have yung samples natin is dependent on each other, no? So kumbaga yung two means na kung saan natin kinuha yung yung mean kung saan natin kinuha yung mga yung data set na yun, they are not totally independent of each other. So usually when we say paired observation, as the name implies, no, naka-pair yung mga different observations natin. So this is mostly applied to cases wherein meron tayong before and after. Parang gano'n, no? So kunwari, meron tayong experiment with a new medication testing their blood sugar levels. So pwedeng yung observation natin is one person. Tapos yung one person, i-experiment natin siya before applying a particular na new medicine. Tapos after in-apply yung new medicine. So in that sense, naka-pair yung observations natin sa before medication and after medication. So another example also is kunwari in metallurgical setting naman is, for example, meron tayong kunwari meron tayong samples na i-heat treat natin. Gusto natin malaman kung ano yung effect ng heat treatment. So pwedeng we have 10 samples kunwari, tapos of that 10 samples kukunin natin yung hardness before heat treatment, tapos kunin natin yung hardness niya after heat treatment. So ang key observation dito is that dapat each unit will experience both population conditions. So in the metallurgical example na binigay ko, na-experience niya yung as cast or as received na condition, tapos na-experience niya yung heat treated conditions. Okay? So always pag paired observation, dahil paired nga siya, dapat yung total number of observations is the same for both cases. Okay? So the most common mistake na nakikita ko when doing case 7, no, is not identifying that it is actually a case 7. So minsan kasi na confuse si case 7 with case 4, 5, or 6. Parang ganun. So, ang pinakamalapit siguro sa kanya is case case 6, no? So if you look at case 6, it's almost similar to case 7. Parang meron kang two data sets, tapos merong variance sa isang data set, merong variance din yung kabilang data set. Pero again, si paired observations, dito kasi sa case 4 to 6, yung two data sets natin are independent of each other, no? So kunwari, yung data set ni dun sa example natin, kunwari, data set ni paint A does not depend on the data set of paint B. Okay? So kumbaga walang one-to-one correspondence tong kunwari itong ano na to, particular data point na to, hindi siya nagko-correspond sa data point na to ni paint B. Okay? So always take note of that, class, no? Kailangan meron tayong parang one-to-one correspondence between observations para ma-consider natin siya as a paired observation. Okay? So there are cases wherein obvious na paired siya, lalo na pag mga before and after. Pag before and after, parang obviously makikita na natin na ano siya, no, na paired siya. Pero there are cases wherein hindi as obvious yung ano, no, pagka-paired observations niya. So kailangan nyo talagang before you decide if it is case 4, 5, or 6, try to look at the possibility na baka case 7 siya. Okay? So ito, meron tayong paired observation daw. A metallurgical engineer or metallurgist wants to determine the hardness of a certain metal alloy. Tapos 20 metal specimens were fabricated and half of which are indented using tip 1 while the other half is um, indented using tip 2. Then shown is the data obtained. Parang ganyan, no? So, dito, although medyo pangit kasi yung ano no pagka-state ng problem kasi we can argue that um yung each metal specimen natin dito is ano no is independent of each other. Kunwari yung specimen number 1 for tip 1 is independent of the specimen number 2 for tip 2 kasi hindi naman sila made or kumbaga uh, yung specimen na yon is independent of the specimen that is given to tip 2, no? So a better way of presenting this information is dapat meron tayong 10 metal specimens na lang. Tapos each metal specimen meron silang replicate. Tapos yung replicate na yon experiences tip 1 and tip 2. So parang ganun yun na lang siya i-imagine, no? And I could probably just ano no para hindi na kayo malito din. Tama? Yeah, kasi if you just read this on as it is, class, no? Parang you could make an argument, you can make a valid argument na sir, case 6 to, hindi naman necessary na ano na paired observations to. Okay? So pwedeng 10 metal specimens were fabricated tapos one with two replicates each. One replicate was indented using tip 1 while the other replicate using tip 2. Ito, pag ganito siya, ito mas obvious na, class, no, na dapat paired observation siya. Tama? So you see the difference sa parang correction na ginawa ko. Hopefully it's much more obvious, no? Okay, thumbs up kung nag-agree kayo or malabo ba? Tingin nyo the same lang? Okay, meron namang mga nagta-thumbs up. So thank you for the feedback. Pero if it's still confusing, class, no, don't hesitate to use your mic or i-chat nyo na lang yung concerns nyo, no, as I go along with this lecture. Okay, so let's try to do this. Meron tayong ano, and I'll just show you the quick method, no. So the long method is that we do something that looks like this, no? We create a table. So meron tayong tip 1, tip 2, get the difference. Get the difference between tip 1 and tip 2. Tapos kukunin natin yung difference niya minus the average difference of the of the different na o of the total na observations. So ito 1, ang average nito 1, 0, minus 2. Ito mga values na to is negative 0.1. So that's 1 minus negative 0.1. Tapos after nan, kukunin mo yung average value niya. Okay? Tapos after nyan, i-plug in mo siya sa equation na to, no? Kukunin mo yung standard deviation of the d value. So let's just do both na lang para mas makita nyo. So if I do this one, okay? Tapos, nasa Excel naman na ako, no? Let's do shortcut muna. Yeah, ito t-test kasi to. So, p-value na yung nire-return niya. So, we can't use that. Ang gagamitin natin is data analysis. Let's do t-test for paired two samples. Ito yung paired observations, no? So, nakasulat dito. Again, tama ba yung ano ko? Nakikita nyo yung pop-up na dialog box? Ito, nakikita nyo to? Itong naka-float around. Okay, thank you. So, t-test, ang pipiliin natin is yung t-test paired two sample for means. Okay? So, variable one range. Ito. And let's include the title na, no? Para, ano. Okay? Tapos, i-check natin yung labels natin. Okay? Tapos, ano bang binigay ng problem? Binigay ng problem is walang sinabi kung ano yung confidence interval dapat, no? So, if walang sinabi, ang rule of thumb class is, lalo na pag in a research setting or engineering setting, is we always use 95% confidence interval. So again, pag walang sinabi, use 95% confidence interval. Okay, so we use 95%, so that's 0.05. And let's output it somewhere dito na lang sa left side. Right side, I mean. Okay, so we should get something that looks like this. Ang importante sa atin is etong T-stat tapos yung DF natin. No, this is degrees of freedom. Sorry. Etong T critical two-tailed. Ito yung kailangan natin. Tapos yung observed difference niya is i-compute pa rin natin, no? Okay? So let's do D1 minus D2. Drag lang natin to. Then we can do D minus D bar. This becomes 1 minus yung average. And again, kasi gusto kong i-drag to, no? I'll press my F4 button para ma-lock in ko siya using the dollar sign. Or pwede rin manually i-type yung dollar sign. When you use F4, nagtatoggle siya between the different parang configurations kung saan mo ilalagay yung dollar sign. So I'm locking in both the column and the and the row. So pwedeng ganyan. So I can end up with something that looks like this. Okay? So ang computation is we need to get the standard deviation of the difference. Actually, hindi na pala natin kailangan tong no? Ano nga? Ba't mo kinuha pa yung DI minus D bar? Parang hindi naman na necessary. Anyway, see, let's do this one. So we do d minus d bar. Ang gawin natin is d bar muna. D bar is just equal to the average. This one. Tapos, yung SD natin, this is the standard deviation of this one. So, hindi natin kailangan itong d minus d bar. Parang saan kaya to? Okay. So, sa pagkuha, okay. Kung ima-manual pala, no? Tama, tama. Kasi ang gagawin dito is equals sum square over 9. And if you get the square root, let me just double check last now kung ito nga ba siya. Tama, ito siya. Okay. Get ko na pala kung bakit ginawa. Thank you, Russell, for pointing that out, no? Nagtaka ako kung bakit kailangan ko to eh. Anyway, hindi natin kailangan pala to class, no? For our case, kasi meron naman tayong Excel. So instead of computing for yung sum square nito minus divided by the total n minus 1, tapos getting the square root of that value, gawin na lang natin is, and I can just delete it, no? I can just do stdev.s ng d minus d bar. Okay? So, E natin, actually, konti lang pala yung gamit natin dito sa ano, no? Sa paired observations. Kasi ito, meron na tayong nandito na lahat ng information na kailangan natin, no? So, yung T lang nakuha natin. So, T is equal to this value. Okay? But I could have very well done T dot in dot 2T ng 0.05, no? And degrees of freedom is 9, which is the same value here. Okay? So my E now becomes equals ito times standard deviation ng difference divided by square root ng N. Tama? Oop. Ano nangyari? Okay. Square root ng, sorry, count lang nito. Or dapat square root ng 10 na lang dapat ginawa ko. Sorry. Yan. So 8.564 dapat siya. Okay. So that's that. So may E na tayo. So ang kailangan natin na is yung final answer, no? Confidence interval. And let me just do negative 0.1 plus minus 0.856. Okay? Tapos ito. Sorry. Again, lagyan natin ng ganyan. Apostrophe para ma-force natin to be a string siya, no? So negative 0.1 kasi ang tendency kasi ni Excel class, no, and you can make this as a shortcut, no, lalo pag full size yung keyboard nyo. If you want to not enter equals, pwede actually ang ilagay nyo is plus 13 divided by 12. Automatic gagawin yung formula yun. Or minus 13 divided by 21. Automatic pag nagli-lead kayo ng with an operation like plus and minus, automatic na gagawin niyang formula yung ano nyo. So, notice na dito, ginawa niya automatic equals negative, ganyan. So, kaya, minsan nahihirapan kayo maglagay ng negative 41 plus Ganyan, tapos gusto nyong gawing text siya. Nag-error siya kasi akala niya na formula rin gusto mo dahil nag-lead ka with a negative or positive or plus na sign, no? Or a minus or a plus sign. So, para ma-circumvent yan, lagyan nyo lang ng parati ng apostrophe, no? So, ang apostrophe is, again, saying na anything that follows after the apostrophe is a string, and therefore I treat everything as a string of text, no? Okay? So, ito yung final answer natin. Okay. So, let's proceed tayo sa lesson, no? Oh. Ito class, itong next example na to is much more, ano, no? Ito hindi masyadong obvious na ano siya, paired observations. So, meron tayong ano, at least for me, hindi masyado siyang obvious. Nung una inisip ko, akala ko ano to, um, nung first time ko na-encounter siya, akala ko parang case 6 siya or case 5 to 6, 4 to 6. Pero if you look at it, meron tayong different companies. Tapos naka-report yung total ROI nila um, from two different periods, no? So one from 86 to 96 and one from 1996 itself, no? Kasi this was a time wherein nag-boom yung industry ata. So kaya siya ginawa siyang study, no? So ito 10 years prior, tapos yung uh, at the uh, at the year 1996. Okay? So this is before and after because each of the observation is one specific na specimen, no? So if you look at Coca-Cola, this is one specimen, tapos meron siyang before, tapos meron siyang after, no? And now that I'm thinking about it, hindi ko na rin sure kung bakit nalito ako, no? Pero medyo obvious pala, no? Or would you agree na obvious siya or medyo confusing siya? Because at first, personally, I found it confusing, no, as to why it was a paired observations. Pero kayo, looking at this, would you say that it is fairly obvious na paired observation siya? Pfizer, napansin. Merong interesting question si Martin, no? So, yung condition po for paired observations dapat same samples or usually po yung data sets are gathered from doing the same experiment different times or possible pong hindi time and relation ng two data sets. So, hindi necessary, no, na kunwari same samples ay um, i or ang same samples yung isa subject mo to the same test. So kunwari yung indentation test, hindi necessary na i-indent mo yung sample specimen 1 tapos with tip 1 and i-indent mo with tip 2. And in fact, erroneous yung ganyong klaseng ano, no, because if you remember your Met 12, when we do indentations, dapat kasi na um, yung tip natin is fairly kumbaga undisturbed yung metal na inaano natin, ini-indent natin. So kaya nagse-separate specimen tayo. Ang importante dito sa paired observations is that dapat same type of specimen sila. Okay? So in this case, same company, si Coca-Cola, i-apply natin siya into two different na population conditions. And the population condition is yung period from 86 to 96, that's one population condition. And another population condition is the period of 1996. So hindi naman necessary time, no, yung determining factor. So hindi necessary na before and after talaga siya. Na pwedeng yung population condition mo is more of a treatment. So kunwari pwedeng one group kunwari, although most of the time nagiging before and after siya, no, kasi since you are treating the same specimen twice, kasi in most cases kasi when we treat the same specimen twice, usually ginagawa natin yung before then after But there are cases wherein kunwari yung metallurgical sample natin, no, na example natin wherein si in-expose natin siya to 2 tips pero yung specimen natin ni-replicate natin siya, then that's still a valid na ano, no, na condition for it to become a paired observation. Okay. So, baka nga nakakalito to, no? Baka yun din yung una kong naisip. In general naman nakakalito yung food, ano, no, lalo na pag hindi niya na fit yung parang basic description na parang before, quote unquote, before and after dapat ang isang pooled standard, ang isang paired observation, no. So yun, medyo confusing siya, pero we just need to, ang siguro keyword na kailangan natin i-understand is that the sample is not independent, no, or yung treatment natin for the data set 1 and data set 2 is not independent of each other. Okay? So meaning si specimen natin um, is exposed to 2 different population conditions, pero that specimen is the same specimen for all for both na population condition na in-expose mo siya. If that makes any sense, no? Okay. Okay, so ito this is fairly simple lang, no? Kaya niyo siyang gawin on your own. You can do the same the same na steps na tinake natin dito sa problem na to, no? So we just substitute in the values. Tapos makukuha na natin yung ano, and paired observations usually mas madali siyang i-compute, no, kasi mas simpler yung formula na ginagamit sa kanya. Okay? Now, next is we compare the confidence interval for variances, no? Or itong case 8 is a case wherein gusto natin malaman kung nasaan naglalay yung confidence interval for a particular variance. Now, you might be wondering bakit importante na alamin natin yung interval for variance, because variances are important because the way we look at how the behavior of the variance is for a particular data set, kaya natin mag-deduct or mag-make ng mga inferences about the population being studied. So parang, for example, if I introduced a new factor tapos biglang nag-vary or tumaas yung variance ng ng response variable para sa data set na yon, then I can say na yung inintroduce ko na bagong factor is actually the one causing the variance. So I can say na yung factor na yon na kaka-affect siya doon sa response variable. And that is how analysis of variance works, no? So kaya siya valid na type of statistical test. Okay? So, pero in this case, more of estimation lang muna tayo. Pero once na we translate this into hypothesis testing, you will figure out na this is the same as just an ANOVA test, no? So, kaya nga tinatawag siyang ANOVA because it is analysis of variance. Okay? So ito, focus muna tayo sa estimation lang muna. So we are trying to find yung interval kung saan naglalay si variance natin, yung true variance that is. And for this case, we use what we call as the chi-square na distribution, no? Now, one thing that we should note about the chi-square distribution, and I should probably show you ito. Let me transfer my screen. So isang importanteng observation for your variances is that they don't follow a normal distribution, no? And hindi rin symmetric yung magiging distribution nila. So parang ang distribution nila is look something like, wait lang klasa. Okay? Yung itsura nila is non-symmetrical, no? And they are skewed to the right usually. So, if I were to draw it, para siyang ganito. So, the thing about chi-square distribution is that eto, hindi rin siya symmetrical around this, ano no, kung eto man yung mode natin, kasi siya yung kung nasaan yung peak. Hindi siya symmetrical. For one, it's just symmetrical. It is skewed to the right. And another thing is that yung if you get a chi-squared value dito, hindi siya equal sa uh, equivalent chi-squared value nito. Tama? Kasi if you have, kunwari, 0.05, kunwari, ito sa left tail natin, 0.05. And since skewed siya, so hindi same yung distance na to, no? Kasi ito, mas malaki yung area niya. Or no, sorry, same area pero mas malaki yung kumbaga yung frequency, yung height niya na, na na mari-reach as opposed to yung dito, no? So, ito this is much flatter. Kumbaga yung parang ano niya, yung area na kina-cover niya. Pero they are the same 0.05 kunwari. So, the thing about it is yung value na to hindi siya tulad ng normal distribution wherein yung value na to is equal to just the negative. So, kunwari negative 1 kung positive 1.7 ang 0.05 na area yung point na to, positive 1.75, di ba sa normal distribution, kahit sa T or sa T test or sa Z test, usually negative lang siya, no? In this scenario, hindi siya equal. So, iba yung value niya dito versus value niya dito. Uh, and all of the values in the x-axis is actually all positive, no? So, if you go to negative infinity, um, it will actually start at if you go to the farthest end ng asymptote na to, this will actually be starting at 0. So 0 siya papunta dyan to a positive value. Okay? So, knowing that, iba yung magiging parang manipulation natin when it comes to the when it comes to determining the confidence interval for uh, your your variance, no? So if you look at this, oh, ito siya. So makikita natin na yung variance natin, this is a confidence interval, no? This is equal to n minus 1 over the variance of the sample squared divided by yung chi-squared. Eto, wag kayong malito dito, no, sa alpha over 2 tsaka 1 minus alpha over 2. And if I make some correction, no, para mas madali sa inyo maintindihan to. What I like to do is, eto, I'll just say, this is the chi-square value for the left tail. And this is the chi-square value for the right tail. Ayan. Think ko mas madaling maintindihan nyo, no, kung ganito natin siya i-layout. Okay? Tapos, yung degrees of freedom natin is just equal to n minus 1. Okay, so let's try to determine yung confidence interval natin. So, let's do this example. Meron daw tayong following weights in decagrams of 10 packages of grass seed distributed by a certain company. Tapos, let's find a 95% confidence interval for the true variance of the weights of such packages, assuming that this is a normal population. So, maybe you're confused, class, no? Kasi sabing normal, di bakit hindi tayo gumagamit ng normal distribution? Because if normal yung distribution mo for the mean, then the variance does not look normal, no? Okay? Kasi ang variance is the change or perturbations ng mean na yon around the or the spread, kumbaga. So which is different from the mean itself, no? So that's why yung distribution ng variance is ano siya, skewed to the right. Okay? So let's do this. Copy natin yung values nito, no? Lipat natin sa Excel. Tapos, wait, gawin natin is space special. Tapos gawin natin is, pwede actually natin i-text to columns to, no? Tapos ang gamitin natin delimiter is space tsaka comma. Okay? So, that's another trick you can do, class, no? So, space and comma. Just finish. Dapat meron tayong number. Tapos, buray na lang natin to. Okay? So, ito yung data natin and I like to move it. Gawin ko to. Yan. Mas okay na i-transpose natin, no? Para mas madali makita. Okay? So, meron tayong data na to. Tapos, gusto natin mahanap um, yung confidence interval for which the uh, true variance lies. Gawin natin is equals standard deviation muna tayo, no? Or variance muna tayo. So, var.s equals var or di po kita, sir, mga pop-up. Okay lang kasi hindi tayo gagamit ng pop-up, no? For this particular case, wala tayong shortcut actually for dito, no? So, gawin natin is, pero thank you, Kenneth, no, for that note. So, gawin natin is equals var.s. Sorry. So, this is var.s equals var.s ng dataset na to. So, this is our variance. Tapos, kunin natin yung or I can just say S squared ano para mas magmatcha doon sa formula natin. Mas kailangan natin is yung chi. Wala kasi tayong symbol or mahirap maghanap ng symbol for chi. So, ang gawin ko na lang is capital X, no? But you get what I mean. Chi squared to. So, we get chi squared ng left tail is equal to chi. Again, chi SQ yung ano niya, no? Yung syntax. Tapos, ang gusto natin is yung inverse. Okay? So, kung left natin, iwan lang natin siya as int lang na ganyan, no? So, the probability is alpha over 2 kasi 2 tail yung gagawin natin. So, chi squared inverse probability is 0.05. 5 nga ba yun? 95%. Yes, 95% yung hinahanap niya. So, we can do 0.05. Degrees of freedom is equal to n minus 1 lang din, no? Tama? Ba't nawala? Wait lang. Okay, na ito. N minus 1 which is just count. Hindi ko alam kung ilan values to. So count minus 1. So I get 3.325. Okay. Now if I get chi squared RT, that is equal to chi squared .inf.rt. Okay, yun yung gagawin natin. 3.325. Sorry, probability is 0.05. Degrees of freedom is count to minus 1. Sorry, minus 1. Or pwede rin actually yung gawin nyo is pwede rin is chi squared inf tapos hindi kayo mag-RT pero ang i-input nyo is 0.97. Sorry. Two-tailed test pala to class, no? So dapat 2.5 yung ginamit natin. Tama? 0.25 dapat. Kasi 0.25 on the left side, 0.25, 2.5% on the left side, 2.5% on the right side. Okay? So, pwede actually itong right tail, instead of doing that, pwede din gawin natin is chi-square.int lang, no RT. Tapos, lagay natin is 0.975. Degrees of freedom, count, minus 1. Okay? It should give you the same value lang naman. Okay. So, we know the left tail, we know the right tail. Ang kailangan na lang natin is to determine the lower limits and upper limits. So, gawin natin is, let's do lower limit. Let's do upper limit. Tapos, yung lower limit daw natin is just equal to n minus 1 times yung variance. Okay? So, sample variance that is. So, lower limit natin is equal to lower limit is equal to n minus 1 count minus 1 times variance, which is this one, divided by left tail. Okay? Tapos, yung upper limit natin is, and I can just copy this to. Pero babaguhin natin, instead of that one, over right tail natin siya. So yung variance natin should lie in between these two values. So confidence interval natin is 0.95 to 0.14. Parang ganyan. So notice na hindi natin pwede gawin yung plus minus, no, because yung wala tayo, ay hindi kasi symmetrical siya. Tama? So kaya siya from 0.95 to 0.14, or hindi siya symmetrical around a 0 point, no. So hindi natin pwede gawin yung parang plus minus e na method. Okay? So it's always a confidence interval expressed as ganito, or pwede rin 0.95, pwede rin ganito. This is another way of showing the interval, no? Is S or sigma squared tapos 0.14. Pwede ding ganito yung pagka-state nyo, no? Personally, ako, mas gusto ko ng ganito lang para mas malinis, no? As opposed to dito. Okay? So, we can do an experiment class, no? And this is one thing that you'll notice. If you do equals over, hindi pala pwede. Iba pala yun. Sige, okay na tayo dito. Okay, so, fairly simple, no? When we have your left tail and your right tail. Tapos, ang kailangan na lang natin is yung confidence interval for comparing um, two variances, no? So case 8 is for comparing or for finding the where the true variance lies given a sample na data set. Tapos case 9 naman is if we want to compare the two variances given two data sets. So ito medyo confusing to na no. Ito kasi from from again mga remnants to ng dating method of using of using the tabular na values. So kaya siya may mga ganitong manipulations, pero what we can do is just say this is equal lang sa left tail of the F test with given new 1 and new 2. Ito. Left tail, tapos ito right tail. Yun, mas simple isipin nyo, no? Oh, wait. May i-check lang ako saglit guys. So, F F tables. Hanap lang ako yung F table ah. Okay. So, para mas ma-explain ko ng mas maayos class no kung bakit medyo confusing yung ano, kung bakit tayo hindi na or bakit confusing yung mga old slides na to using the old tables kasi if you look at old tables, ganito kasi yung old tables. So, I'll show you. Okay. So, old tables look like this, no? Ito siya class. So, notice na yung X niya comes from the right tail, no? Or yung probability niya, kung yung area niya, kumbaga, comes from the right tail, papunta dito sa left tail. So, going from right to left siya. So, that's why medyo confusing yung the way we interpret it, no? Kasi si Excel always comes from 0 to infinity. So, from here, 0, mag-move siya to the right. So kasi old tables natin have they always take the right tail na probability, no? Pero nakasulat naman na right tail probability siya. Some tables pwede ding left tail yung kinuha niya pero most of the time right tail yung kinukuha. Kaya dun sa mga old na ano natin, may manipulation sila na kunwari 1 minus alpha over 2 or alpha over 2 yung kailangan mo exactly because of this, no? So kaya gusto ko na ang gawin na lang natin is uh, binago ko yung formula to just mean left tail and right tail. So kayo na bahala compute kung paano nyo makukuha yung left tail and right tail. But as long as you get the exact or the correct chi-square value or area under the curve given uh, a particular na problem, no? Okay? So I hope that makes sense. So kaya ini-emphasize ko parati na left tail and right tail parati gagamitin natin. Okay? Now, etong si class, for this case, baguhin natin to, no? This is always, yung degrees of freedom 1 is always the degrees of freedom of the numerator. And degrees of freedom 2 is the degrees of freedom of the denominator. So para hindi kayo malito, gawin ko siyang ganyan. This numerator, denominator. And denominator. So, titingnan nyo. So, in this case, for example, ito, the numerator is sigma 1. Therefore, dapat yung df1 ko should be the sorry. Should be the numerator. Tapos yung df2 ko should be the denominator. So, just look at kung paano siya yan. Kasi kung pag nagko-compare tayo, remember, ito pala. Sorry. This one. Ito, no? So, this is the numerator and denominator. So, sigma 1 natin is, data set 1 is numerator, data set 2 is denominator. So, whoever is the numerator will be df1. Whoever is the denominator will be df2. Okay? So, this is df. Minsan df yung nakalagay, minsan nu yung ginagamit na symbol. No? So, that they just mean degrees of freedom. Tapos, notice na dito sa comparing variances, you'll notice na hindi siya difference, no? It's actually a fraction. So remember kasi na hindi symmetrical around the symmetrical around the zero yung distribution niya. So kaya hindi pwedeng plus minus yung magiging interval niya. So yung magiging ano niya, parang comparison for comparing variances is actually fraction, no? So either numerator ka or denominator yung data set 1. So ganun siya kino-compare. Okay? Okay. So again, always para hindi na tayo malito kasi yung old formula na nakakalito, no? Gagamitin natin is always left tail, yung i-multiply natin sa lower bound, tapos right tail yung i-multiply natin sa upper bound, and knowing na sigma n natin will or the new one is always the numerator and new 2 is always the denominator. Okay? So, let's try an example. Ito, this is the same example as kanina, no? Yung two companies. Tapos, hanap tayo ng itong two companies na to. Gusto natin i-compare yung two variances niya. Okay? So, let's just say, ito yung first company si numerator, second company si denominator para hindi na tayo malilito, no? Pero pwede nyo pa rin i-represent siya as denominator, baliktad, no? Na numerator to, tas denominator yung first data set natin. It will mean the same thing, and I can probably show you if may time pa tayo, no? Although medyo kulang pa tayong time. Okay lang ba mag-extend tayo ng konti? Siguro extend tayo ng 10 minutes. Pero kung hindi, continue na lang natin sa next discussion before we start with hypothesis testing. Okay, so let's do F muna. Yung F values. Sige, compute muna natin yung different na variances muna kasi yun yung importante. var.s natin equals var.s ng this data set. Baba natin. And bukod sa variances, do we need another count? We need count, no? Equals count. And apart from that, wala na, no? Okay. And I could probably just lagay ko na lang dito yung formula para tayo. Okay. Okay. So, pwede tayong maglagay ng df din dito, no? df equals count minus 1. So, pwede ko i-drag dito. Okay. So, let's compute for f left tail. So, f left tail is equal to f dot inf. Again, always dot inf yung ginagamit natin, no? If we are trying to look for the x-axis na value niya given a certain probability. Okay? So, f dot inf probability natin is on the left side. So, we do 0.025. Is this 90%? 90% pala siya. So, since 90% yung hinahanap, so ilagay ko na dito, no? 90% confidence interval. Oh. Since this is 90%, gagawin natin is f left tail equal to 0.2. Sorry. F dot inv ng 0.1/2. Degrees of freedom 1 is the numerator. This one. Degrees of freedom 2 is the denominator. This one. Okay. So that is 0.16226. Okay. Next is F sa right tail naman is just equal to F dot inv dot RT. Probability is 0.1/2 ulit. Degrees of freedom 1. This one. Degrees of freedom 2. Now, there is one interesting property dito sa F distribution class, no? If I do F dot inv or 1 over f dot int nung 0.025, tapos baliktarin ko yung degrees of freedom, I do 6 and 4. What I end up with is actually the, sorry, 0.05 pala dapat. What I end up with is actually the right tail. So kaya dun sa original na equation, naalala nyo yung original equation before ko binago to left tail and right tail. And hindi ko, I have to check the modules again, no? Kung ano yung ginagamit nila. Pero if you remember dito, yung original equation niya, actually may mga 1 over pa siya. So, let me, kung gaano kalayo yung mga control C ko na hindi naabot. Maybe, I'll just open it again. No? Ito class. No? So, kaya dito sa ano, if you look at the original na are we viewing the same? Ito. Ito yung original. No? You notice that ito 1 over f alpha over 2 ng nu1, nu2. Tapos ito 1 over, this is f alpha over 2 ng nu2, nu1. Okay? So, ito actually left tail siya nung inverse pag binaliktad mo yung ano, yung two values, yung dalawang ano. So kaya nagwo-work to. So again, this is because always right tail kasi tayo nag-ano no. Sa if you look at the statistical table, parang right tail test siya. So dito sa case natin, pwede actually i-manipulate nyo siya para mahanap nyo yung right tail. Kaya dito, the same siya, no? And if you do 1 over inv ng RT, F inv RT ng 0.05, degrees of freedom, baliktarin natin, ito, tsaka ito. You'll notice na ito, this is equal to this left tail here. Okay? So doon nagaling yung original. So para sa akin confusing na kasi ito lalo na at hindi naman na tayo gumagamit ng statistical tables. Pero eventually no gagamit din pala kayo. So importante din naman to pero if we are using Excel hindi na natin kailangan malaman yung ano no. So pwedeng LT, left tail lang i-compute natin tsaka right tail na lang para automatic na. And always, yung numerator is the first DF1, denominator is the second na degrees of freedom. So yan, at least hindi na tayo mag-iisip ng kung babaliktarin pa ba natin yung numerator and denominator or mga ganyan. Okay? So, we have the F values. So, ang kailangan na lang natin is yung ratios. No? So, yung lower limit natin is equal to variance ng dataset 1 over variance ng dataset 2 multiplied by the left tail. Tapos yung upper limit natin is equal to variance ng dataset 1 over dataset 2 multiplied by the right tail. So, confidence interval natin is the true comparison or the two fraction between sigma 1 squared over sigma 2 squared is equal to is somewhere between 0.011 and 0.33. Okay? Yun yung interpretation net. Okay? So, this is comparison of ano. And I think medyo oversaturated na kayo ng information siguro. We can stop here, no? But I want you guys to look into, sige, kaya na siguro. 5 minutes lang last. What if baliktarin natin, no? Sigma 2 over sigma 1 naman ginawa natin. So, if that's the case, ang FLT natin, so ito, this is a case wherein 1 over 2 tayo. 1 over 2. Tapos ito naman, or para mas malinaw, 1 over 2. So ito, 2 over 1. Pag 2 over 1 yung ginawa natin, this now becomes f dot inf ng probability natin is 0.1 over 2. Degrees of freedom ng numerator is this one. Tapos denominator natin is dataset 1 naman. So nagbaliktad siya, no? Tapos gawin natin FRT equals f.inf.rt. Ang probability natin is 0.1 over 2. Degrees of freedom 1 natin is numerator over denominator. So you get ganito. So notice na magkaiba talaga siya, no? But let's try to look at this, no? So lower limit natin will be numerator over denominator multiplied by FLT. Denominator natin is upper limit is equal to this one. Sorry. Equals to numerator over denominator multiplied by FRT. Oh. Binago ba ako? Sorry. Parati na lang hindi ko binabago yung ano. Okay. So ito, ginawa ko lang yung same steps class, no? Pero ang ginawa ko is binaliktad ko yung mga numerators and denominators, no? So ito, f in ng 0.1 over 2, numerator naman si company 2, denominator si company 1. And similarly sa RT naman, f.in.rt equal to ganito over ganyan. So notice na kung if I take the inverse, 1 over equals 1 over this value, then this is just equal to this one. If I take the inverse of this value, then this is equal to this one. So it makes sense, no? Tama? Kasi kung ang fraction ko is if yung sigma 1 over sigma 2 or yung variance 1 over variance 2 lies between 0.011 and 0.33, then kung binaliktad ko yon, yung ano tawag dito? And this is what I think you learned this from math na siguro, no? Ito, if I do something like this, if for example, meron tayong ganito, no? X is greater than Y. Pag tinake natin yung reciprocal, magiging 1 over X is babaliktad yung inequality, no? 1 over Y. Parang ganyan. Naalala nyo ba to? This is, ano bang math yun? Math 17 sa amin eh. Hindi ko alam kung anong math nyo ngayon. Ano ba mga math nyo ngayon? Sumasagot. Mga math 17 pa ba kayo? Math
22.
22, math 22. Okay, 22, 21. Sa saan ba to sa math 22? Yung basic na ano ba to? Algebra. Advanced algebra ba?
Tinanggal na po ata, sir, kasi parang sa senior high.
I get. So, probably sa senior high na laman nyo na to, no? Yung pag nag-change tayo ng inequality. Kung meron tayong isang inequality, tapos nag-reciprocal tayo, magre-reverse actually siya. So, kaya nagme-make sense na eto, pagka ni-reverse natin yung ratio natin, instead of sigma 1 over sigma 2, sigma 2 over sigma 1 yung ginawa natin, it makes sense na if you take the reciprocal, yung lower limit magiging upper limit na siya. If you take the reciprocal, tapos yung upper limit magiging lower limit siya if you take the reciprocal. Tama, no? Wala lang. It's something interesting lang, no? At least I find it interesting. So yun yung relationships ng mga left tail and right tail natin. And if you take into account yung Kaya dito sa lalo na sa F-test class, no, sa when we're doing um variances, analysis of variances na, no. So hindi lang ANOVA pero yung general na when we analyze variances, usually very important kung ano yung in-establish nyo na numerator and denominator kasi that will dictate kung ano yung um, degrees of freedom nyo doon sa ano. Kasi when we do this, there is always 2 degrees of freedom, no? May degrees of freedom 1, degrees of freedom 2, and you need to adjust accordingly para makuha nyo yung correct na F F na F value, no? So just be very careful and again, think of it in terms of numerators and denominators lang. And in fact, in some tables, no, instead of saying DF1 and DF2 or nu1 and nu2, usually ang sinasabi nila is DFN, DFD, which indicates numerator and denominator. So, okay na siguro. Nag-extend tayo ng konti, no? Medyo ubos na rin yung boses ko and I think super saturated na rin yung mga utak nyo, no, sa natutunan natin today. Meron tayong quiz. Dalawa lang yung quiz natin. Kasi again, sa ano kasi, Triple ME14, tinanggal na namin yung modular quizzes, no? So, ang mangyayari na lang ngayon is meron lang tayong tinatawag na teacher's quiz, no? So, teacher's quiz will depend on the teacher. Tayo will only have 2 quizzes, no? Isang quiz for probability, tapos isa for hypothesis testing. Yun lang yung gagawin natin quiz and it's a simple quiz, mostly ano lang to, no, multiple choice lang or either multiple choice or simple identification, so walang masyadong calculation. We leave the calculation for ano. Okay lang ba na i-send ko yung quiz later today? Tapos ang deadline niya is bago tayo mag-exam. Although since medyo late ko na inano, ang exam naman natin is scheduled on the 16th. Kaya pa naman, no? Medyo mahaba pa naman yung oras. Okay. Thank you, Martin, for the replies, no? And yung iba, okay lang ba? I hope it's okay with you guys, no? If ever hindi siya okay, kunwari kulang talaga kayo ng time, pwede naman, sabihan nyo lang ako. I'm very flexible naman tayo sa ano, no? Yung quizzes naman, more of ano lang siya ng formative type of assessment para lang malaman ko na before the exam na at least medyo nagigets nyo yung concept, no, na involved in Triple ME14. Okay? If you want also guys, no, bago tayo mag-exam, I can hold a sort of review session kung gusto nyo lang. I can probably do that. Tapos pwedeng mag-rundown lang or hindi naman siguro review session, more of consultation session na lang, parang ganun. So I can do that. Tapos siguro kayo na lang magbigay ng schedule sa akin kung ano yung mas parang preferred nyo na schedule. Ang iniisip ko dito is gawin natin, since exam natin is 16th. Wait lang check natin schedule. Exam is on the 14th siya, 14 to 16. So, since Wednesday class natin, 7, pwedeng 9 kung gusto nyo sa Friday. It's a Friday on the 9th. Magkaroon tayo ng parang kahit 1 hour consultation or review session lang. Hindi natin gagamitin yung buong 3 hours. Pwedeng 10 to 11:30. Parang ganun. Yun yung naisip kong schedule, no? Top of my head. Pero kayo, kung gusto nyo other schedule, just inform me. Tapos check ko yung schedule ko. Okay? So, talk about it as a batch. Tapos, parang inform nyo ako kung ano yung preferred schedule nyo. Tapos, we can probably April 14, 14 to 16. It's a 2-day exam that is no. No, so sorry. 16 to 19. I'm sorry. 16 to 19. April 16 to 19 is 16 is a Friday. Mali pala yung sabi ko. Wednesday pa lang 14. So 16 is tama pala. 9 yung sabi ko pala, no. 16 to 19, that's a weekend, no? So from Friday to Sunday. Okay? Okay, so medyo ano no, draining tong araw na to, medyo this is the point wherein usually class no, during estimation, hypothesis testing, and pataas, parang dito na nagkakaroon ng medyo parang medyo mahirap, nagiging mas mahirap na yung lessons natin no, from this point onwards. Okay, so feel ko naman kaya natin. We can get through this sem, and hopefully we pass with flying colors now. Okay, so thank you for coming today, and I'll see you the next week. No, next week is Holy Week, so I hope you uh have a energizing rest, no? So sana makapagpahinga tayo lahat. Tapos I'll see you the week after that. Okay? Happy break, guys.
Thank you, sir.
Okay.
Thank you, sir.
Okay. Goodbye. End ko na yung class na.